Okay, this is actually the last page. It might be the fastest notes we've ever done. This is the entire unit. So inverse matrices. If A and B are inverse matrices, then A times B times A equals the identity matrix. So that's the result. If you multiply two inverse matrices, kind of like to tell the way you're going to figure out that they're inverse matrices is that when you multiply them together, you're going to get the identity matrix, whatever the dimensions are. A non-singular matrix is a matrix that has an inverse C. A singular matrix is a matrix with no inverse. I don't know. I always felt that was kind of counterintuitive. I figured a non-singular would have no inverse and a singular would have an inverse, but it's the other way around. So it's counterintuitive. And we see this a lot in math where you think it's one thing and then it's something else. So just, study it, and this is not going to be in the test, so don't worry. All right, so now, how do you find the inverse of the matrix? This is going to be important for the matrix project. This page is probably the most important page for that project, but I needed to give you all that background information so you could do this, okay? So we're going to find the inverse of the matrix. I'm going to go to that other TI CAS and get that inverse button for you. But for you guys, it's actually right below the matrix button. And again, that's done on purpose because you're going to be using this a lot. So you're going to type in the matrix in your calculator. So you go to second and then x inverse, which is matrix, over to edit, make it a 2 by 2, and put in 3, 1, 2, 1. So this would be like your matrix A, we call it. That's a 2 by 2. And all you do in your calculator is do A inverse, and then it's going to spit out 1, -1, -2, 3. I remember I had to do these by hand in college. They were not fun. All right, and then now you're going to multiply. So 3, 1, 2, 2, 1. You don't have to do this. I'm just showing you this is the check. Times 1, -1, -2, 3. And if you multiply them, you're going to get 1, 0, 0, 1. So that's how you know that they're inverses of each other. You get the identity matrix. So like over here, if you do the same thing, we call this B if you want. And then you do B inverse. And what it's going to tell you is no inverse singular matrix. All right. And this last one, I'll do it with you guys. So I know that it's going to stop, so then it'll just continue. It'll flow into the next video. Okay, so we're going to go to the TI CAS. Oh, it worked. Awesome. All right, TI CAS, let's delete everything here. Okay, so now my matrix is a 3 by 3. All right, so I'm going to enter these numbers in. So 1, -1, 1, 0, 2, -1, and -4, -5, and 0. All right, so now let's see if I can do this again. Where is the inverse button? Ooh, eigenvalues. Let's see. You know what? It's probably got its own button here. Come on. All right, let's see if this works. So I'm gonna enter it again. Answer. Let's see if it does it like this. Okay, yeah, it worked. Great. So all I did is I raised it to the negative first power, which is the same thing as finding the inverse, and I get 5, 5, 1, -4, -4, -1, -8, -9, -2, and that is the inverse of that matrix. Okay, so again, 5, 5, 1, -4, -4, -1, -8, -9, -2. Now the whole point of doing this, the whole purpose is to solve a system. And again, there's another way of doing this. If let's say you don't want to do RREF, like you're like, oh, I don't know where it's at. This is a much easier way of solving the matrix. So to solve for the variable matrix X, which we're calling the variable matrix, it's going to be A inverse, which is the coefficient matrix, times B, which is the constant matrix. So you're going to be finding the inverse of the coefficient matrix and multiplying it by the constant matrix. So really your only thing you're going to do by hand is first translate it to its constant matrix, coefficient matrix, and variable matrix. So it's going to look like this: 6, 17, 3, 9. That's the coefficient matrix times the constant matrix, the variable matrix, xy, equals the constant matrix, or like the solution matrix, 16, 2. And if you think about it, it's kind of like division, but a division doesn't exist in matrices like how you and I think about division. So instead of doing division, what we're doing is we're going to try to get this matrix by itself. Do not put that in your calculator. You don't want to have variables in there. We're going to try to get that matrix by itself, but instead of dividing it by this, which we can't do in matrix world, we're going to instead multiply by its inverse. And that's what you get here. So now the variable matrix, xy, is equal to the inverse of 6, 17, 3, 9 times the constant matrix. And you could just put this entire thing in your calculator, and what you're going to get, again, it's not going to say xy, what you're going to get is a 2x1 matrix, 36.66 repeating, negative 12, and that just tells us that x equals 36.66 repeating, and then y is equal to negative 12. And again, the nice thing about it is with these larger matrices, which are sometimes pretty tough to find by hand, so if you have this matrix in your back pocket, this is great. So now all you're going to do is translate it: 1, negative 1, 1, 0, 2, negative 1, negative 4, negative 5, 0, and then x, y, z, and then 0 to negative 6. Oops. Okay, 0 to negative 6. Okay, all right. And now we just, make our transition here. We're going to rewrite it. So the thing we're solving for, x, y, z, is equal to the inverse of the coefficient matrix that's 0 times the constant matrix. And you put this in your calculator, it'll spit the answer out. And again, once you get used to entering the matrices in your calculator, it gets faster. Okay, 4, negative 2, negative 6, x, y, and z. Okay, so that was the entire unit. And then I'll show you in class, if you want, show you in class, or maybe I'll do a couple pages of the matrix project on a video to help you see how this relates to the matrix project. Okay? All right, stay safe. There'll be more to come.